All right, so I think we are good. Although my network is kind of breaking, I don't know why that is happening. I'll try and reduce this again, just to 2.5 frames per. Yeah, the bit rate was too high, so let me just see if I can go below it. All right, I think now it's better. Um, this network is really bad, but yeah, I just manage like this for today. All right, so um, I started this problem yesterday, and I was supposed to finish it today. So it is the longest palindromic substring in a string S question, and this is a medium question. Well, yeah. So what this question is asking is to find the longest string, like the longest substring or the longest string that is part of a bigger string, which is a palindrome, right? But then we want to find, the longest palindrome we can get in a bigger string, right? So here's an example. We have S equal to BABAD, right? But the longest substring, right, the longest palindromic string we have in this string is this BAB, right? Because BAB is part of the bigger string, so yeah, it is the longest. We also have ABA, right? This is also a valid palindromic string, but it is not the longest since we've had a longer um, substring. We just kept it like that. Otherwise, if we had something else that was longer than this, then we can write that instead. So my brute force solution here yesterday. So what I did is I had to, let me just remove this again. I'll just go over quickly and explain what my solution is going to do. All right, so here we are. Now, first of all, what I want to do is to target a group of item in this main string S, right? So um I mean, a palindrome is a string that can be read the same way from right to left and from left to right. So the first so here's what I'm going to do. I'll have another string, right, called S, right, and I'll add two pointers at this position, or let me just call this string called, I'll just call it sub, right. Sub has is a string that is a valid palindrome, right. So here's what I'm gonna do. I'll take two pointers. I'll put two pointers in the string S. I'll have a left and a right, right. Now these two pointers will create a substring for me. I'll have, for the first time I iterate over the string, I'll have item at B and item at R. This will be BA, right. BA is our first substring, but BA is not a valid palindrome, right, because BA is not the same as AB, right. This is not the same. So um this is not a valid palindrome, so we move r to the right. Right, r will be at this position, and then the next time we'll have b a b. Now this b a b is a valid palindrome, so we each time we create a new string, we'll run a check on that string. So b a b is a valid palindrome because b a b is also written, when you're writing it backwards, right, you'll still write b a b, sorry, BAB like this. This is the same as this one, although we are writing them, in different directions, right? Now, after we found a valid palindrome, right? This palindromic string, substring, has a length of 3, right? It has a length of 3. So we continue looking again. What's the next item we can get? So since this is a valid palindrome, we continue because we want to get the longest possible substring. So we move r again to the right. R will be at this position. Now the new string we'll get at this point, sub, is going to be BABA, right? BABA is not a valid palindrome, right? And since BABA is not a valid palindrome, it means we can now move the position of the left pointer to create a new pattern, right? Because we previously had a valid palindrome, right, which is BAB, right? But the next time we move the r pointer to the right, we did not get a valid palindrome. So which means no matter how far we go, right, we will never get a valid palindrome. So we need to move the left pointer towards the right. So which is why I moved this. So we have L at this point. So the new substring we'll have now will be from L all the way to R. So it will be A B A, right? So this another valid valid palindrome, because ABA can also be written ABA, so it's still the same thing, right? So this is a valid palindrome. We move R to the right, right? R is at this point, so we have another, oh sorry, we have another substring again. I'll just put the sub there, substring, and this substring will now be, so from this point here it will be A B A and ABA ABAD, right? So this ABAD is not a valid palindrome, right? Because we can't write it the same way in the other direction, from right to left, right? It will read differently. So since this is not valid palindrome, we move L. We don't move R anymore, we move L. So L will be at this point, and the string created, right, sub, will be equal to, you know, um, BAD, right? Bad. So bad backwards will read dab. So this is not a valid palindrome. We move L again, L to the right. This will be equal to AD, right? AD is also not a valid palindrome. So we can't move R L anymore, right? The left pointer anymore. At this point, we've already reached the end of the string, right? Because R is already here. So when we increase this and it is equal to the R, it means we've reached the end of the string, and we can only take the first longest substring that we had, which was BAB, right? BAB, right? This is the first one we got. So we can use this as our valid palindrome. It has a length of 3, although ABA also had a length of 3, but this was the first one we found, right? We wanted another one that would be longer than this BAB, but we didn't get that, so we just used this instead as our valid palindrome. So the steps will be so I'm just going to do it this way. So step one is to create a substring, right? A substring, okay? Is to create a substring. Then step two, check check if the string if the string is a valid palindrome. I'll just put valid pal, right? And then the third step after checking, right? If it is a palindrome, right, we add it to, let's say, a map or a dictionary, whatever. But um I'd prefer using um I would not use a dictionary per se. Hmm. But well, the reason why I would use a dictionary is to find the length, right? To keep the length and compare it to the length of others so that I can, change it later on. Mm, I mean, if it's a valid palindrome, right? If valid, right? If it's a valid palindrome, store. I'll just put store with length, right? We know that we have a valid palindrome here, and so if it's not, store with length and then increase r. Otherwise we don't increase r at this point. So increase the r. Else, if it's not a valid palindrome, we want to increase l. Want to increase l to create a new string, to create a new string. All right, let me go ahead and try this out. Although there are sub steps, between each of these steps here, right? There are other steps that are involved in these steps, but I don't want to write everything out. I'll just use this as a guide to my YouTube. Is not. This is horrible. Somebody said, which language is best, Python or C++? I don't use C++. I only use Python and mostly JavaScript. Yeah. And PHP. Yeah. Well, Python is like one of the best. Okay, so let me go ahead and implement this. Um, I'll just start with this first one here. Um, so what's the title of this? The longest palindrome, right? So I'll just type that longest palindrome. So this is a two pointer problem, right? So new Python file, longest what? I want to use abbreviations. Longest palindromic substring. I'll say longest PLS. Longest PLS. Like this. Um, what's the number 5? Wow. Question number 5 dash 5. Yeah. So I'll just come here and take the boilerplate code like this, and yeah, we can start with the different steps we set in place. All right. So the first thing is to have two pointers, right and left. I'll call these right and left pointers. So I'll put right is equal to 0 and right comes after left, right? So I'll put left is equal to 0, and then right is going to be equal to 1, so that we start from the next item in the string. Now before I even do this, right, what if the string was just a single letter, right? A, like this. A is a valid palindrome. A is a valid palindrome because A can be written the same way, you know, like this. A here is a valid palindrome. So we need to, keep in mind some of the edge cases that you know might just cause some trouble in the future. So A is a valid palindrome. What if we had C A or B A? I'll say no. Let's say A B, like this. A B is not a valid palindrome, but what is the longest substring, right? Which is a valid palindrome in A B? It's going to be one letter, right? It's going to be A, right? So meaning A, B, C, D, right? If the entire string is not a valid palindrome, then the longest substring that is a valid palindrome is a single character. A is a valid palindrome. A is a substring of A, B, C, D. B is a valid palindrome. C is a valid palindrome, and so on, right? So if the string's length is 2, right, we can return the first character as the um, longest substring, right? But that is also tricky. What if the string is just A and A, right? A and A. We want the longest substring, right? The entire string doesn't really matter to us. This A and A is good, but this longest substring, which is a valid palindrome, is still A. So yeah, that is good. So I'll just come here and I'll say, before I even create anything, right, I'll say if length of um of the string, right, is equal to 2. Okay, if the length is equal, not just 2, but if the length is, less or equal to 2, right, we just want to return the first character in the string. So s at 0, right? This will be our valid palindromic substring, right? Whether the string is 2 or 1, we still have one character being returned. Now here's what I'm going to do. Let's move on to our main business. Our main business is to go through the entire string with our pointers, and then validate them each time to see whether it is a valid palindrome or not. So to do something like that, when we have two pointers and we are creating a new string out of the pointers, we can use a range, right? A range to create that string, the substring that we want to validate. And to keep the loop running, right, there's supposed to be one more how do you call it, one more um what's the word for this, one more condition, right, that will keep the loop running, which is as long as right is not equal to left, right, we just want to keep the loop running. So um while while right, or while left, let's just start from left, since left is the smaller one. While left is not equal to right, not equal to right, then this loop can keep going on and on. So I just do it like this, And what do we do inside the loop? Well, we want to create a substring, right, based on those two um, pointers here, right? So how do we do that? Well, we can use a range, right, to create. Let me just show you an example. um, if I had, okay, I've closed, okay, I didn't close it. Well, I can close these ones here, right? If I had a string like this, I'll call this s equal to a b c d, right? Oh, a b c d, right? Let's say my, okay, let me just say aba. You know what, that's not the point. So I just want to create a substring out of this entire string here. So to do that, if I had a and right and left pointer, right and left pointer, I'll say this. So the right value is going to be 0 and the left value is going to be 1, right? So all I need to do is to run a loop based on those values, right? So I can just, which means I want to take a substring from a to b, right? So here's what I'm going to do. So I'll say for I in range, right, in range, so the starting point of our range is going to be right, and then the last point where the loop has to stop is going to be right, right. Oh, sorry, it's going to, I'm not starting from right, I'm starting from left, sorry, left all the way to right, right. So if this is 0 1, that means this will stop at 0 here, but we want 1 to be included in the this, so we'll do +1 here. All right, so let's just create our substring. I'll say um just s s, okay, let me call this sub is equal to an empty array. I'll just use an array and create a string from it afterwards. I'll say sub dot append so we want to take each character from the string s, so I'll say s at I, right? So it will append each character to the string, and I'll print print um print right sub. Okay, I want to join it as a string, so dot join sub, like this. So when I print this, you will see the printed value, or the output, is going to be AB. So let's run this. We don't have anything yet because AB. Oh, okay. Right. So this was printed at the same. It didn't run synchronously, right? So it's asynchronous running. Here's what I'm going to do. So I'll just create a function, right? I'll say print sub sub substring, just like this. Sorry, Christ. Print just like that, and I will not provide it with any parameters because I know what I'm going to use. So at the end of the day, I want to return the substring, right, in a string form. So this dot join, and we want to join it with what, with the substring, so sub here, like this. And I'm going to print this out. So let me just say print sub, print sub, like this. This is just going to work now. What am I doing? Current file, I'm still not seeing anything. Why is that? Sub dot append. So I'm starting from 0. What's the, oh, you see, this is my mistake. Hold on. You know what? This can be confusing sometimes. left has to be 0, right has to be 1. Yeah, so this will work. For range left, right, right plus 1. Sorry, 0. Let me just put this like 0, 1. Oh, sorry, I wasn't printing out anything. Uh, Silly me. Okay, so print here like this. And you can see we got AB as our substring, right? This AB. So that's exactly what we're going to do. And then the string we return from this combination will be what we, test for our valid palindromic function. So here's what I'm going to do. So while left is not the same as right, so our left is 0, our right is 1. We can also do it this way where it's in a single line. So left, right, and then 0, 1. So this is also valid. I actually like this way of doing it. Instead of having like multiple lines of code, I'll just put this like this. Okay, so we have left and right. So while left is not equal to right, this is going to take a lot of time to compute, but um um that is what Let's Code is asking us to do. So we are going to create our substring, right? We are going to create our substring, and I'll just use like a function, right? I'll create my own function as part of the class. So I'll just define a function here. I'll say create substring, right? So create substring is a function that takes you know a certain value, right? A certain string. um this is not going to, it's just a normal function. It's not a function of the class. So um create substring, and then what I'll do is I'll pass it a string, or I'll just say a character. I'll pass it a character like this. Come on, I want to pass it a character, and this character, hmm I'll call this ch, right? This character is going to be, oh sorry, I need to put self. Sorry, do I always need to put self? As I don't use, okay, so I'll put a character here and say this character is going to be a string, and sorry, self comma, right? This character is going to be a string, right? And I want to return another string from this function. At least at the end of the day, I want to return a string. So um, str is a string, and then I'll just say, okay, so since I'm returning a string, um, okay, I'll create a substring array. I'll call this substring, right? Substring. You know what? This is, oh, that's not what I wanted to do at all. This is going to create a function in the class. So this is not what I wanted to do. I want everything to be part of this string. So I'll from a part of this function. So I'll just have a substring like this, right? Equal to an empty array, right? This is going to be a substring. Then I'll create my function, right? My function is going to be something like this. And what this function does is to append a character to this substring here. So here's what I'm going to do. I'll say substring, right? Substring. I want to create a substring for it, but I'm also thinking, why do I even need to, create it this way? Can't I just append to a string like this? Okay, sorry, like this. Would this work? Well, this does not have append. I doubt. Yeah. So we can only use lists for this. Um, yeah. Okay. It's totally fine. There is no constraints per se as to, how much time um the compute. I mean, the big O of this, but we always aim for a better big O, which is going to be O of n at least, because we are working with strings and arrays, so we don't want to go quadratic time. We just want to stay within a linear time complexity. All right, so this is substring. Yeah, so our substring, we want to append an item to a string. I don't think we even need a function at this point. We don't need a function here. I wanted to create a custom function to handle that for me, but it seems it's just too much. It's just too much. So what I'll do instead is, while left is not equal to right, I want to create a substring. Um, so the substring is going to be for I in range of um, left. We want to start from left and then right plus 1. Okay, left to right plus 1, and we want to append this to the string. So this is what the function does. That is basically everything. So I'll just do for sorry um substring dot append. What's that? They've taken the lights, but the inverter is working. So append, want to append what to it? Yeah, character at I. So want to append um s is our string, right? S at I. So every time this loop runs, we add one item to the string. Now this is just creating a substring, right? But when do we use the substring for, say, you know because the code will run synchronously, right? So it will first of all create the substring for us. We'll have a substring, then we'll validate that substring and see you know if it's a valid palindrome or not, right? So now I'll just say, I'll call this a valid substring, right? So the next thing to do is to check if the substring we just created is a valid palindrome. So a string is a valid palindrome when it can be written the same way forward and backwards, right? So the same, in different direction, but it will be read the same. So here's what I'm going to do in that case. I created a palindromic function before, but let me just do it again. So the palindrome is going to take a string, right, and then loop through that string to find which so let me just create a function here. I would need to create a reusable function, so I'll just say def validate, let me just say validate string, right? This would take this would take um this would take a string, right? So this function would take a string, and here's what's going to happen. So s is going to be a string. I'll not call it s, let me just call it sub, right? Substring, or let me spell it for substring, is going to be a string, sorry, string, and the return type is going to be a boolean, right? So it's going to be a boolean value. Oh, sorry, I don't have to spell the string. Like this str is enough. Now, how do we check if a string is a valid palindrome? Again, we have to look through, create a map, and all of that. Ah, this is, since I don't have like any weird characters in the string, I can just do it this straightforwardly. So here's what I'm going to do. First of all, I don't even need pointers. I need to create a map. All right. So I'll say, um, you know, palindrome map, and set to equal to an empty dictionary. This is going to be an empty dictionary, and then what's going to be the next thing? So yeah, I'll loop through I for I in range again. I want to use a range so that I can take the indexes as my map keys. So range in length of substring, length of substring. Let me type this like this, substring, yeah, substring, like that. Okay, then here's what I'm going to do. Oh, this function is going to kill me. This is hard. um Let me just close this sidebar as it's taking unnecessary space. um so here's what I'm going to do. I'll say palindrome map, palindrome map um at palindrome map at I. So this is going to be my key, and then I'll just say substring, substring, substring at I, right? So this will create a map with the keys as the index, right, at I. Or let me just call this J, 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 and then J, right? So this is going to be J0 and the character at that point. So here we have, this, and then what I'll do next is to loop through and find out, loop from the back. So for, I'll call this what other variable for H? No, IJ. Okay, so for K in range, now I want to loop from the back forward. So I'll say range of, so I'm starting from the back, -1, right? Oh, sorry, length of the substring -1, -1, -1. Okay, so yeah, so if the current item here, right, okay, we created a map, so I need a pointer here. I'll just call this a pointer again. My pointer is going to be set to 0. So this pointer's value is going to increase every time I look into the string from the end to the beginning, right? In every iteration, this pointer is going to increase. Now, the role of this pointer is to actually compare the keys in the in the palindrome map that we created. So the palindrome map is going to be, let me just represent something here. I'll come here again to my board. Where's my board? All right, so we have a palindromic. So let's say I like this example so much. RAR is a valid palindrome. So the palindromic map is going to look something like this. We'll have 0 at R, 1 at A, and then 2 at A like this. Oh, sorry, 2 at R. The value here is R. So 2 at R. Um, oh, hey, thanks so much, Prasad. Thank you, thank you, thank you. All right, so let me represent this properly. So this is going to be 2 at R like this, and here. So that's what we have. This is what our map will look like, right? Now, when I'm looping from from the end of the string towards the beginning, it means the item that appears at the end has to be the first item in the original string, right? Because if I'm going to write this backwards, it's going to still be RAR, but if I added some indicators here, right, it's going to be R2 A1 and then R R0 here, right? But we can't use this 0, 1, and 2 to compare it with the values here. So, which is why I need a pointer. I needed a pointer, sorry, right? My pointer is going to be 0. So, each time I loop through this string, right, I want to increment the pointer by 1. So, here's what's going to happen. R2, right? Let me erase this. R2 R2 here is going to be the first item we see when we are looping from the end to the beginning. So R2 is going to be our value, but we want the first item in this string, right, to also be R, right? Forget about the base here. The base doesn't matter. We want it to be the first item here, but we can't use these two here to compare it here, because when we use this two, it's going to point to this item in the map, but we want it to point to the first item, which is why I'm using a pointer, right? A pointer will increment every time I go through the string, but the main point of the pointer is such that you know uh its value is going to always point to the first item in the string, right, in the map. So at pointer 0, the value is R, right? The value is R, and you know in the original string, the last item in the string is also R, right? At pointer 1, right, the value in the original string is going to be A as well, but this time around we are looping from the back. Now let me show you why this actually works for you know for you to actually understand. This is why this solution works so well. I'll just remove everything and use a string that is not a valid palindrome and test this theory out. Let's use a bar, right? BAR is a bar. Now the map for this string is going to look something like this. We'll have B is our first item. Sorry, the first item is going to be at index 0 and B is going to be the value. At index 1, the value is A. At index 2, the value is what is R, like this. Now this is our map. This is what our map looks like. So we want to okay, this is off the screen. I'll just bring this back here. Oh god. Yeah, so that is now in our frame. Now let's see, when we start looping from the end to the beginning, the characters have to match at each point, right? Now what at what position is this last item here? This last item is at index 2, right? We can't use index 2 to check in the string code in the map, because at index 2 the value here is R, right? We don't want that. We want this to point to the the first character in the main string, right? So, and the first character is at position 0, which is why I need a pointer, right? My pointer is always going to start from 0, right? Regardless of how much I'm moving towards the left, right, from the end to the beginning, I want my pointer to correspond to every value in the map. So at pointer 0, right, which means when the pointer is equal to 0, I'll just move. When the pointer is equal to 0, it means I want to check in the original string what is the value of the first character in the original string. And for it to be a valid palindrome, right, the character has to be the same as the last character in string, right? In the reverse of the string, right? So here we have an arrow at the end, so which means at pointer 0 we obviously want the value to be r as well. But when we look into the map here, the value here is not r, the value here is b, right? Which means this is not a valid palindrome. And that's all. That is how we can check, if the string is a valid palindrome or not. So yeah, so here we just say if so I'm looking right. So we are looping. Okay, so if pointer 0, okay, if if item at pointer 0, so if the item in the string, right? So what's our map? Palindrome, sorry, palindrome map. We want at this pointer, right? If this is equal to the value of the substring at key, right? Substring at key like this, then we want to increase the pointer by 1. So pointer plus equal 1, right? We want to increment the pointer, so it means we found a match. Else if it's not, we just want to return false, right? Return false. Otherwise, when we don't return false, when we don't return false and the loop is done, iterating, we can return false at the end. We can return false at the end of the string. So I'll just say return return true, return true in the end. So here is our valid palindrome, okay, let me just call it valid power string, right? This is the valid palindrome string. So here's what we're going to do. So the string we created here, right, is what we are going to put into our valid palindrome function. So valid palindrome function. So I'll say if if it's a valid palindrome string, so the string is just going to be something like this: s.join. I don't want to run this operation all the time, so I'll just say here, I'll just say s is going to be equal to, not s, it's going to be, what, the name is just so hard. I'll just call this string to be, right? String to be, come on, string to be is equal to, I'll create the string back from the array, so join the substring like this, right? String to be, and I'll just say string to be here like this, right? This is going to be our string. If this says, okay, it's a valid palindrome, right? It's a valid palindrome, then we can keep the current valid palindrome string and also increment r. So here's what I'm going to do. What do I do? I think I should just okay, so I'll just say palindrome found, right? Palindrome found is equal to an empty string, right? This is going to be an empty string. So when we see if this is true and we validated this and it's a valid palindrome, right? We also want to check if the previous palindromic string that we found, we want to get the length of the previous string, right? Even though this is an empty string, we still need to get the length so that we know, okay, this is, the current one we found is higher, then we set it to the length of that. So let me say, so if length of length of our previous our original palindrome found, right? Palindrome found. So if the length of this is less than the the string to be, right? If it's less than the string string to be, right? Then if it's less than the string to be, okay, sorry, if it's less than the length, sorry, if it's less than the length of the string to be, less than the length of the string to be, then we want to set the palindrome found to be equal to the string to be, yeah, like this. So now our palindrome form is this. But in the case where, you know, this is not palindrome found. Okay, so in the case where we this is not a valid palindrome, right? When we tested the substring we got, it's not a valid palindrome. What do we do? Before I even get to that, right? After finding a palindrome, right, we need to increase the right pointer by 1 plus equal 1, right? Um, yeah, so let's come here. Let's come to this case again. Now, if we validated the string and it is not a valid palindrome, what happens? Um, if it's not a valid palindrome, obviously we want to move the right pointer, the left pointer, and the right pointer, right, simultaneously. Um, so in that case, um, in that case, thank you. So in that case, I want to check if there was already a palindrome found, right? If we already found a palindrome, then so I'll say else so else if elif, right? Elif we don't find a palindrome. Um if we don't find a palindrome and so elif we don't find a palindrome, right? Obviously this will just skip and come here, right? So we don't even need to check again, right? If we don't find a palindrome, we want to know. So if we don't find a palindrome initially, right, and we the string we got here, sorry, if the string the substring we created here for testing, or this string to be, is not a palindrome, we did not have a palindrome previously, then we can continue moving the right pointer towards the right, right? So that's what I'm going to do. I'll just say elif if you know, the length of the, sorry, let me see, what's a substring? It's an empty string, right? I'll say print print not empty string, like this. What's going to happen? I'll get through, right? So okay, I'll get through. So I don't even need to check the length equal to 0. I'll say if not um, a palindrome found. So if we did not find a palindrome before, right? If we did not have a palindrome before, right? So well, we want to increment the right pointer. We just want to keep increasing the right pointer, right? So right plus equal 1. Else, right, if we had a palindrome before, right, if palindrome found, right, we had a palindrome previously, right? If we had a palindrome previously, then so let me just say print um so this in this case, right, um with if L is else if palido found, right? I'll just test this again. I'll say pal is equal to an empty string, right? If not not pal, right? If not pal, just print just empty, print empty. Otherwise, if pal, right? Print 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 not empty. Okay, sorry. So we'll get empty, but here we'll get not empty. Okay, so let me close this. So if there was a palindrome before, and after validating this string we don't get a palindrome, palindrome, we want to increase the left and the right. So left plus equal 1, and then right plus equal 1. Okay, so every time, right, so we can increase the left. This is going to take a lot of time, but I mean, it doesn't, it costs no harm to try. So okay, so I'm increasing left and I'm increasing right. If we already had a palindrome string and we did not find a valid palindrome, right, you know what, instead of doing it this way, right, I'll just say if we don't find a valid palindrome, right, then just straight away else what happens next, right? Then we can say if not a palindrome, right, we want to increase r, else 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 we want to increase left and right together. Okay, I'll just remove this from here and indent it properly. Okay, now this is okay. If we don't find a valid palindrome, right, if the string we are testing is not a valid palindrome, then we come here. If it's not, if we didn't have a palindrome previously, right, we want to increase only r, right, we want to increase only r. Otherwise we want to increase r and left, I mean right, we want to increase only right. Otherwise we increase left and right. But this is also a problem, right? Because now we had a palindrome previously. Well, this is not going to work as expected. The reason being that, you see, when we don't find a palindrome, when we test for a string, right, and it's not a palindrome, and we had a palindrome previously, let me come here again. If we had a let me just take all of this. The string we're testing was, I think s was equal to, s is equal to I think a d, right, b a d, yeah, that's correct. Well, what my solution is saying, if we did not have a valid, so I'll just call this pal here, right? This is our old palindrome that we found. This is the match that we found, right? So if we don't get any match and this is empty, right? I'll put my L and R here. We continue incrementing R, right? But here now we have a valid palindrome, right? This is a valid palindrome. So we set this to um we set this to BAB, right? But the next time we increase R, right? And this is not a valid palindrome, right? What do? We want to move L to here, right? Oh, okay. So this is a valid palindrome, but we don't set it to, unless the length is longer than this. Yeah, I think that's it. That's it. This is okay. So in the end, I want to do this. So if not a valid palindrome found, we want to increase the right pointer if we don't have any. But what if yeah, the only time we want to increase L is when we already have a palindromic string. Previously we found one match, and the subsequent strings that we look into, right, are not valid palindromes, right? So we continue incrementing L and R, right, till the end of the string. It actually makes sense now. Well, at least that will work. That's going to work. Um, but we don't want, R to increase out of bound, right? We don't want R to go all the way out. So if and R, I mean, I'm saying R right? The right pointer is less than the length of the. We don't want the right pointer to increase all the time, right? We don't want it to go out of bound, because this will just escalate, right? So what is condition that only increases this when possible. We only want to increase the right and left only when it is possible. And I don't want to add many if checks here, right? So what do I do now? I think um what I should do, because if I set this to, and that condition, then I might just end the loop when arrow reaches a certain point. Meanwhile, we could just keep continuing increasing the left pointer. So that is not good. I need a very, very valid way to. Oh, my camera has gone blur. I don't know why. Okay, it's focused back. So I've done 1 hour already. Wow, time is running. Um, I'm still thinking, right? What's the best way to do this? I don't want R to go, all the way to the end of the string, and I don't want. Okay, so as long as left is not equal to I, right? Okay, can I use or? No, and And yeah, I mean, when one of these becomes true, nah. Okay, so both of them has to become. F- I mean, this when this becomes false, I mean, it takes everything away. So this is not. This is out of the question in the first place. Right. So what do I do? I only want to increment. I mean, this works when we are incrementing. Um, I don't want to increment R all the way. If we don't find a valid palindrome and R is still not at the end of the string, then we can create R. Right? I'll just do it this way. It's this is not the time to write the perfect code. Just to test out. I can improve on it later. And R, sorry, I keep calling it R. I don't know why. And right is less than the length of the string, right? The length of the string, right? We want to keep this like this. You know what? This yeah, yeah. This prevents that. Okay. Okay, it's fine. It's fine. So, okay, this is good. This is good. So if the length of the palindrome is less than the length to of the string to be, and again, and our right is less than the length of, oh my god, this is some repetitive stuff. um I'm not going to shy away from the fact that I have not thought about a better solution for this. But yeah, so if this is happening, else we can increment this, but we also don't want to increment it when um sorry. Oh my god, there are too many conditions here. Else if the if right pointer is less than the length of the string, right? If the right pointer is less than the length of the string, then we want to increase it, right, with the left altogether. I mean, we can increase left regardless of whatever right is. Right, left, left will, you know, at some point increment to the value of y, and this will just stop. Now, okay, so we've done all of this. In the end, we want to return a string, right? So longest palindrome is string, and I'll just return this palindrome found here. I'll come here. This function is quite long. Let me just, what's this? Okay, so I want to return, re common, return palindrome found, right? I'll expand this back again, and let me just test one case here, right? So string, oh sorry, solution is going to be equal to palindrome, sorry, solution, the solution class. Let's create an instance and I'll print. uh, I hope I hope this is okay. So print um, an instance of this. So solution dot longest palindrome. I'll use this string here. I'll use a string here. Okay, I've gone to open the wrong app. This string here. Come on. I want to use this string. You know, this string here like this. Yeah, I'll use this string and see what my solution is. Okay, I knew this something like this was going to happen. So string is out of range exactly. I was expecting that, but not this early. Okay, and the reason why this is happening is because you know of this range here. At some point, the string got to the end, and we are still incrementing right by one, right? Um, so right plus one, if right right is less than the length of of um of s, right? Else just do right. Less than the length of s, yeah, or else just do right. Okay, this is returning ba. This is not what we want. This is not what we want. We want bab should be our. Oh, I see. I know why. I know why this is happening. Because when we append to this string here, right, we get a new value. We get a new value. This is not what we want. Um, so, I mean, before we append, we have to empty the string. How do we empty the string? This, we don't even need to do this like this. We can even define the this stop string here, because I don't know, we don't need it outside, we only need it here. We only need it here, and it might not work here because it's not defined. It's not defined. It's not defined. Oh, that's sad. Well, we don't. It's not there. It's going to be here. It's here. Yeah, that solves our issue. Stop it. What's going on? Oh, we had an infinite loop. Woof. So range of the substring for I range of this. Wait, there was an error. What does this error say? Um, keyboard interrupt in range of substring, length of the substring here. You know what? Instead of let me not just complicate everything. I'm appending to a string. I'm joining the string here. This will create the string every time. So you know what? Let's just. I'll take it back to where it was. No vex, and I will just each time before I append to the string, I can just empty it first, right? I can empty the string. I'll set it to an empty string already. So this map check. Oh, well, ah, this is not fair. Instead of doing substring here, I'll just do, you know, character like this, right? I'll use character everywhere. Or I'll say, let me just say, okay, you know what? Use substring, lists, right? And I'll say this is lists and then lists because the program is confusing the functions. And yeah, so that's our first. This is still happening. We are having BABA. Yeah, okay, so I said I would empty the string first, right? I'll empty it first before we continue. So I can just say substring list is equal to an empty string, right? I mean, we can do it here. I can bring it back here. Oh, my time is remaining 3 minutes. Christ, Jesus. Okay, no, no way. We can't do this here. It's not going to work because we need that function too. Um, I mean, it didn't work. This is an infinite loop, so don't let my program crash. I'm just going to. How do I empty? I need to create. You know what? Instead of me doing it this way, right? I'll just completely remove this from here, right? That's not anything. So, I mean, I can just create. I don't even need this, right? Join. Um. What if this was an empty array? Nah, this will cause an infinite loop. And why is that? Why is that happening? It is causing an infinite loop in BABAD validate. Oh, that's strange. Um, string right plus one if the right is there. Okay. Mm, oh, I see. I see why this is happening because I mean it's not getting any condition to terminate the string, and I'm saying so while right is not the same as left, and there has to be another condition because I mean unless we increment the right, the left pointer, right has to keep going. Oh, I'm doing something very, very wrong here. This was supposed to be easy. Um, I mean this created B because this string here previous. If I print, let me print. Let me print string to B. You'll see string to B each time will go from, yeah. So it will print BAB. So it went from this to this. Oh, well, R would have must have increased by one. It didn't even move. So we have BA, which is the first. In the first iteration, we have BA. In the second iteration, we're supposed to have BAB, right? We have BAB up to this point here. But the reason why there's BA and then AB again is because the string here, right? This here did not change, right? It's still the same array. Like it's appending values to the string. Let me just substring list, right? This here. Instead of it to create a new string, it's just doing the opposite. It's just adding to whatever was there before. You can see BAB and then it added again, it added, it added, it added. Instead, what's supposed to happen is to have BAB and then not this but like BAB up to this point here. And then the next time from this point all the way to this point, sorry, from this point all the way to this point, right? And here it is not a valid palindrome, so the pattern will change a little and then it will go from here all the way here, right? From here all the way here. Oh god, 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 god. I see. I see what I'm doing wrong and I am supposed to change this. Oh, my time has ended. I'll give myself another I'll give myself another 20 minutes. Yeah, or 25 minutes. Okay. How do I do this? So, here's what I'm going to do. Oh. You see, I think. Oh God, no way. I completely forgot about this. I completely forgotten. I, I mean, I didn't even need the loop, right? I could just slice the string. Ah, I could just slice the string. I didn't even need this. I didn't need this loop to create a string, right? I just remembered now. If I had a string, I'll call this str string a b c d. Ah, that's it. I didn't know. So print. I would like to print. Between a certain range, right? I could just do string. How did I forget about this? Anyway, string from a certain point. Like let's say our left pointer is at 1, right? Zero, right? From zero all the way to now. The way this slice works is, if I print this now, it will print everything from zero all the way, right? But when I add one here, right? What this means is it will stop at one. So it will not include one, right? It will stop at one. It will stop here, right? It will not include it, but it will stop here. So to get one, we have to do this, right? Have to do something like this, A and B, and that's how you get a substring from a string. So meaning, we did not need this for loop here at all. So string to B, yeah, string to B can simply be, you know, our s, right? We'll take the right and then the left, sorry, the left and the right, left before right, left and right, right plus one, right? This is what we need. But now this is going into, an infinite loop. This has gone into an infinite loop. And why is that? Well, the reason is, palindrome map of J. Wow. So it did not only, so here is where we are having another issue. If it's a valid palindrome, right? If it is a valid palindrome, I mean, I don't even need this right to, well, I still need it. If it is a valid palindrome, right? We want to check if that valid palindrome has a length less than this, right? Than the string to be, and the right is less than, you know what, let me see where the issue is coming from, because here the situation seems okay. We want to increment the right. If not, we want left. I think so. String to be left to right, right? We can get a string from here. But what exactly is the issue now? Right? I think the issue is from here. Let's just remove this first. This takes a string, right? And I mean, if the value at this pointer is this, we want to increment pointer by 1, okay? But also, I mean, this is how I checked. I did solve the valid palindrome here. don't understand what's going on. Um, okay, so um, I'm using k in range of this, right? K substring k. Interesting. This is interesting. You know what? Let me just print what this is in the first place. A call to this function would do something, right? So print validate the string to be, yeah, string to be, print the string to be as well. And what I'll do is I'll just increment left and right at the same time. So regardless of what is happening, we just want to end the loop. Right plus equal 1, left plus equal 1 as well. Okay, sorry. Right, let's see. Oh, okay, this function is causing an issue. I see, I see. It's just printing. Oh, why is that? Why is it doing that? So I created a palindrome here. Oh, okay, okay. This is where the issue is. Ah, I see. I mean, what happens when right is at the very, very edge? What happens when right is at the end? We can still have a palindrome in between, but we want to stop the. This function is not the issue. It is this other function here, this one here, because this condition here says um, if left is not equal to right, right. I mean, we don't want it on top. Yeah. So this stops the loop, but it creates a new issue for us. Yes. We have BA, right? We okay. Um. Yeah. I think. I think that's was our issue. Uh. I mean, we don't want to increment R, and also we don't want to increment. You know, the left. We don't want to increment the right when it's already at the end, and we don't also want to increment the left when it's already at the end minus 1. Okay, so we're still having true false. Let me, okay, these functions are still printing. I'll just remove these from here. And we don't also need this, but I'll just leave it there for now, in just in case I need to come back and look at it. So I'll just run this function again. It is working now. Yeah, so we have BAB as our, you know, first test case, which is really awesome. So this BAB, the output is supposed to be BAB. So we have BAB here. Let's see what we'll have here. We should have BBB. So um, when I print this function here, I should have BBB. If it works, then we are good, right? Fingers crossed. Let's see. Oh, there is nothing. What happened? What happened? I mean, to do CB is not a valid palindrome. So we move to this place. This is also not a palindrome, a valid palindrome. Oh, I see. Then we are here. So we move all the, okay, okay. So which means that, ha, there has to be a condition where coming. Let me copy this. The conditions are supposed to be such that if we'd already seen more than two items, we'll know it is time to move um, the left pointer, because there's no way, wait, there's no way after a third item and we don't see a valid palindrome, we'll see it at a fourth item, you know. It's always going to be somewhere in the middle. So yeah, that's what I'm going to do. I will just say, okay, if we've not found a palindrome yet, and the right pointer is this, okay. Now, as if we've not found a palindrome, right? If we've not found a palindrome, and the length of the string is of the left the string that we are looking at is like increasing rapidly, like crazy. So um so elif um not palindrome, not palindrome found, and the length of the string to be, right, is superior to 2, right, then we know we want to increment the left pointer at this point. Want to increment the left and the right. Do we need to increment the right as well? I don't think so. We don't need to increment the right. We just need to increment the left, right? Um, and the right. The left and the right. I mean, this will work, but okay. So we only have. If the wait, let me print the string to be again. Print string to be, right. When I print string to be, and so string to be went from CB to CBB to CBD, and then to, it went, oh, we didn't even get the chance to have like CBD before going to CB. I mean, before going to this point, we needed C CBB. I mean, we needed BB. BB is a valid palindrome now. So I mean that means um this condition did not run at all. It didn't run because this condition is still true. If this, right, if this, let's run this first. If this, if not palindrome, and this, right, if not this and that, I'll just take this like this. I'll just say if not, if, okay, I don't even need to put it like that. So if not, not palindrome, and I'll just remove this. I'll just take all the way. Okay. So if we've not found a palindrome and the length of the string is superior to 2 at this point, we know we want to move the left pointer, right? Want to move the left pointer as well. Else, if simply not, wait, what? Oh god, hold on, I'm doing the wrong thing. Oh, I was at the wrong place all this while. Sorry. This is the point where I needed to make that check. So, I mean, if the length of, if this is not a valid palindrome, right? This is tricky, and at this point, I think this is weird. So, I mean, we found the length of the palindrome, right? That we previously had. The length is less than the string to be. Okay, so if the string to be now, oh, okay, okay. So if we've not still found a palindrome, right? And the length of the string to be is superior to, okay, so that's the first check we have to do. So if not palindrome, right, if not palindrome, and the length of the string to be is superior to 2, right? If it's superior to 2, then we want to increment left the left pointer by 1. So plus equal 1, right? Else if, right, just normal else if. Yeah, now this should work. um this should work for us. I'll just, let me remove the print here. Print to be should go, and let's see, we should have BB as our answer here. Okay, we have BB here, that's good. And we want to have for the second one, let's just print both and see what we have. We should have BAB and then BB here. So let's just go. Okay, these test cases are working, and let's test this out in Let's Code and see what the answer will be. So for I in range, I need to remove this. We don't need this anymore, and we don't need this either, right? I mean, that's just Let's Code, so clean up. I just want to clean it up quickly so that we have, well, we don't need this part. So I'll come here and paste this here. I'll just paste this here and see what this will do for us. All right. Moment of truth. Let's run this. Um, okay. We passed the test case. Well, this this still doesn't mean it's going to pass the final stage, the submission stage. But yeah, can wait. I know something will happen and it will fail. I just know. Yeah, this is taking too long now. Yeah, it's wrong answer. Right. What? Oh, it's even 4 out of 142 cases. This is crazy. Um, I mean, why is B not the longest substring? Right. I think this is the case. This case is just this edge case that I have here. I mean, before even creating my function, I need to put that there. Otherwise, I'll just remove it, right? Palindrome found is this, and that. Mm, let me see. And put this here. Yeah, this like be like my first edge case, and I don't even need to return. Just if it's less than two, right? Oh, you can't do this. You can't do this. You can't do this. If I say return S, right? I mean, this, sorry, this will work here, but like the submission itself is going to fail. What if the string has two items that are different, right? Um, wrong answer still. You see, this is what I was talking about. Ah, AC is not supposed to return AC. Okay, so if there is string, oh god, I mean my pointer is not even starting from um is not even starting if this function was doing this right, if I had set you know I to be at 0, right, this will just take the first character. This will not even work. I can't have them as 0 0, right? It's not possible. It's just going to create a scandal. So I mean, for strings that are like this, I can just say, okay, fine, if you're, you know, right? So if the if the length is equal to, sorry, if the length of s, right, is equal to 1, right, just return s at 0, the first item, right? If it's just 1, just return at s at 0. I don't even need to do it this way. I'll just say, right, so if I'll have a separate condition for that, if length of s is 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 an empty string, let me just go to the description and see. Can our string, the length has to okay, so if it's 1, right? So if the length of s is equal to 1, right? I just want to return that particular string. So return s at 0, right? Else, I mean, if the string is the length of the string is I mean between 0 1 so if it is if it's 2, right? If it is 2, right, I want to check if the item at 0 is equal to the item at 1. So if s at 0 is equal to s at 1, right? If then return s, otherwise else just return s at 0. Okay, just this. I think this is okay. So we don't even need I don't even need the s, right? So I don't even need this else condition, but yeah, at the end of the day I can just return it at else if they are not the same, right? I just want to return it as 0. Alright, it's third submission, and let's see how far we'll go. Is a runtime error. Okay, so what happened? Oh, if here is if. Time exceeded. Wow. Time limit exceeded. Um, I knew something like that was going to happen because for CCC, are you serious? The time exceeded for. Come on, this is not true. I mean, I could just let me test this here. How long will it take to execute this? Oh, okay, that's true. It runs into an infinite loop. And why is that? Oh, here. Wow. I mean, we don't need as long as left is here, right? Oh my god. This this shouldn't have been okay, it's fair that is a medium question. I mean, um CCC. Alright, is there an editorial for this? It's locked. Transfer to view this solution. Okay, the video. You need to subscribe. Okay, I don't want to view the video. I'll just look at. Yeah. I'll just look at the solution here. We can start with a brute force approach. We'll simply check if each string in the palindrome, and would check if if each string is a palindrome, right? And take the longest one that is. Hmm. First, let's talk about how we can check if a given string is a palindrome. This classic problem, this is a classic problem, and we can do this with 2 pointers. Of course, we are doing this with 2 pointers. If a string is a palindrome, the first character is equal to the last character. Yes. The second character is equal to the second last character, and so on. Okay. Um, we initialize 2 pointers, one at the start of the string and another at the end of it. One at the start and another one at the end of the string. We check if the character at the pointers are equal, right? If they are not, we check if they are not, we know the string cannot be a palindrome. If they are equal, we move to the next pair of characters by moving the pointers towards each other. We continue until we find a mismatch or the pointers meet. Okay, if the pointers meet, then we have checked all pairs and we know the string is a palindrome. One bonus to using this algorithm is we frequently exit early on strings that are not palindromes. If you had a string of length 1000 and uh the third has 0 byte, oh yes, the algorithm after 3 iterations. Okay, there is another optimization we can do. Because the problem wants the longest palindrome, we can start by checking the longest length substring and iterate towards the shorter length substring. This way, the first time we find a substring that is a palindrome, we can immediately return it as an answer. I didn't think about that. So first, create a helper method, right? This is my own helper method. Validate palindrome string, right? To determine if a substring is a palindrome. Of course, to save space, we will not pass the string itself. Instead, we'll pass 2 indexes representing that. Oh, that represent the source string. I didn't think. Uh, the first character will be SI and the second character will be yes. Oh, in this function, we declare 2 pointers, left, which is equal to I, and right, which is equal to. While left is less than right, we do the following step. If left I is not equal to the right, we return false. Otherwise, we increment left and decrement right. If we get through the while loop, we return true. Use a for loop to iterate variable length starting from s length until 1. This variable represents the length of the substring we are currently considering. So use the for loop to iterate the variable starting from 0 until and including s minus length. This variable represents the starting point of the substring we are currently considering. In each inner loop iteration, we are considering the substring starting at start until. Let me see the code first. I don't understand the last part, but yeah. So we check I and J. These are going to be so left and right, while left is less than right if left is not the same as right. If the s are left, then I get return false. Return false if left is not the same as right. Return false if left plus, so s are left, s are right. So this string is just checking for a palindrome, and here we are starting from, we are creating a range of the strings we want to. Okay. Alright, I think my time is up. I will continue tomorrow. It's already late now, so